Hi, welcome to the video tutorial series from LearnCAx. In this video, we are going to learn about fluid domain extraction. Fluid domain extraction is a part of CAD cleanup, which is in fact a step involved in pre-processing. The objective of this tutorial is to show how to extract the fluid domain from a given CAD model using ANSYS ICEM CFD. In order to demonstrate this, we are going to use a CAD model of an intake manifold. Okay, now we have the ANSYS ICEM CFD software opened and the working directory is all set. So let's move on. The first step is to import the CAD model into the software. To do that, I am going to use the import geometry option available under the file menu. Under this option, you can see a number of file formats listed out. But as we have our CAD file in step format, I am going to select step or IGS option, and from the browse window, select the CAD file you want to open and press apply to complete the import process. This will take some time depending on the file size. Now we have the geometry loaded. This includes points, curves, and surfaces. Once the geometry is imported, the next task is to understand the geometry. To have a better visual on the geometry, make use of the shaded display or just render the surfaces. Now rotate the view and get comfortable with the geometry. The idea is to understand the geometric features and also the fluid flow path, that is where the fluid enters the domain and from where it exits. In case if you see any surfaces that are not being rendered properly, you can right click on the surfaces in the model tree and say show full. This will resolve the issue. This imported CAD model is a perfect solid model, and it has more geometric details than what is required for a fluid flow analysis. What we need for a CFD analysis, that to fluid flow analysis in particular, are the surfaces that are in direct contact with the working fluid. Those are nothing but the inner surfaces of the solid model. They are often referred to as wet surfaces in CFD terminologies. We need to separate these inner surfaces from the outer surface. It will be difficult to select the inner surface while keeping the outer solid surfaces visible. So we need to select the outer surfaces, separate it in a different part, and then work on the inner surface. But before doing that, we need to delete all the curves and the points in the geometry. Let's use delete curve option and select all appropriate objects, but make sure delete permanent checkbox is on, and then select all appropriate objects to delete all the curves, and use delete point option and select all appropriate objects to delete all the points. Now switch on the surfaces in the display and then right click on parts from the display tree and create new part. Now we are going to create a new part for solid surfaces. So let's give an appropriate name to it. Let's say solid surf, and then start selecting the solid surfaces from the GUI. Remember, these are the surfaces which are not necessary for fluid flow analysis or which are not in direct contact with the fluid. You can rotate the view and then continue selecting the surfaces which are connected or which are the outer surfaces. Move to an appropriate view to help your box selection. Okay. I guess we have selected almost all the solid surfaces. So now I'm completing the selection by pressing by middle click. Okay. Now if you notice, we have a new part created, and it is under the name solid surf, and we have all the solid surfaces which we have selected a while back. Now let's switch off the solid surfaces and have a closer look. If you see, there are some surfaces left out that should have been added in the solid surfaces. These are also the unwanted surfaces for fluid flow analysis. These are the surfaces which are connecting the solid and fluid wet surfaces. So I'm going to right click on the solid surface and say add to part, and select these surfaces which are left out earlier. And complete the selection by middle click, and done. So now we have all the solid surfaces in a separate part. Now we need to create a new part. Right click on parts from the display tree, and the new part, we will name it as manifold wall. Make sure the solid surfaces is switched off and it's not visible on in the graphics window, and select all the visible entities right now and complete the selection. So now we have two separate parts. One has the outer surfaces and the other one has the inner surface. I guess now we will have a better understanding of what we have done till now. To summarize things, we have imported the CAD model in ANSYS ICEM CFD and then separated the outer and the inner surfaces in two different parts. Please remember, whenever I say inner surfaces, I am referring to those surfaces that are in direct contact with the working fluid. Sometimes it's called wet surfaces. Now it's time to delete the unwanted solid surfaces, and then we will be left with only the necessary fluid or inner surfaces. You can also directly delete the unwanted surfaces instead of separating them in a new part. But in that case, there is a risk or chances of necessary surfaces getting deleted. So directly deleting the surfaces is not advisable. Now switch off the manifold part from the display, and then delete all the visible solid surfaces using the delete surface option. Now you can either use box selection, or you can directly select items in a part. So select only the solid surfaces and say accept. So this will delete all the unwanted solid surfaces. After doing this, all we have is fluid touching surfaces. The last step to do is make this into a watertight geometry. This is a necessary condition for meshing. To check whether our geometry is watertight or not, we need to use the build diagnostic topology option under repair geometry in the geometry tab. Topology is nothing but how things are connected to one another. We can use this option to obtain boundary curves and points. ANSYS ICEM CFD assigns some color codes to these curves to differentiate them based on their connectivity. For example, the curves that are connected to more than one surface, or in particular two surfaces, if the curves are connected to two surfaces, it will be in red color, and the curves that are connected to a single surface will be in yellow color. These color code will help us finding the location of the hole or leak in the geometry. Whenever you see a loop of yellow colored single curves, that is an indication of hole, and that needs to be closed to make it a watertight geometry. In our case, the yellow color curves are there at the location of manifold inlets and outlets, which shows the geometry is not watertight yet. This set of single or open curves can be closed using the simple surface option available under the create or modify surface in the geometry tab. Give appropriate name and select the set of curves to create inlet and outlet surfaces. I am going to start with the inlet location. Let's give a proper name to it. Let's say inlet, and then select these two curves over here to create the inlet surface. Now let's create the outlet surfaces. I'll give a name, let's say outlet 1, and then select these two curves. Now let's say outlet 2, and then select these two curves. Similarly, outlet 3 over here. If you notice, as soon as we created these surfaces, the color of the curve, which was yellow, turned into red because now it has two surfaces on either side. It is connected to two surfaces, so the color is red. So once again, switch off the surfaces and check for yellow color curves. If you don't see any loop of yellow curves, we are done with the fluid domain extraction. Please note, I am seeing loop of yellow curves. This is because when the geometry involves any thin wall surfaces like baffles, there are chances of one single curve to be present, and that doesn't mean there is a leak. So you should always look for loop of yellow curves. So you can save the geometry using save geometry option. Till now what we saw was a regular way of extracting the fluid domain. There is an alternate way of doing the same thing but with less time and effort. We'll discuss more on this in the next part of the video. Hi, this is the second part of the video tutorial fluid domain extraction. If you haven't watched the first part of the video, I would advise you to learn the concepts from the first part and then come back to this video. As I mentioned in the end of the first part, I am going to show you an alternate way of extracting the fluid domain or separating the inner and outer surfaces using subset option in ANSYS ICEM CFD. As we have already discussed more on importing the CAD model in the last video itself, I am going to rush through some steps and focus more on the new steps. So let's start importing the CAD model. Right click on the curves in the geometry tree and say show wide. And I'm going to render the surfaces to have a better visual. Now right click on the parts in the display tree and say hide all. Now start displaying the first part in the list. Look out for small thickness surfaces which are connecting the outer and inner surfaces. For example, the one over here. I'm going to delete this surface, the thickness surface which is connecting the outer and the inner surface. So after deleting, you can see a small gap, or the connectivity is broken between the inner and outer surface. Similarly, you can find thickness surfaces or connecting surfaces at the other end of the part. So select those parts carefully and delete those surfaces also. So now you have completely broken the connectivity from between the inner and outer surfaces for this particular part. Do the similar thing for the rest of the parts also. So I'm going to the second part, and in this case, this is the surface which connects the inner and outer surfaces. So I have deleted that, and similarly we are going to delete the connecting surfaces for the third part also. So I'm going to switch on everything. Now we can see the connection between the inner and outer surfaces are completely gone, and we can see some gap between the inner and outer surfaces. Now delete all the curves and points, and then run build topology from the repair geometry option. Now we are ready to use the subset option to extract the inner or wet surfaces. Right click on the subset under the geometry tab and say create. Select any one of the inner surface. You are free to select any inner surface, but make sure you are not selecting any of the solid surfaces. And let's give a proper name to it. Let's say wet surface, and then complete the selection. Now you have created a new subset with the name wet surface, and what's in the new subset is one of the surface which belongs to a fluid touching surfaces. Now you can switch off the surface visibility from the display tree, and still you will be able to see the surface which belongs to the subset. Now right click on the newly created subset and say modify, and this will open a new window in the data entry zone. And now select add layers to subset option, and under the flood fill option select all attached method and press apply to see the magic. Yes, this will add all the attached inner surfaces into the wet surface subset. Now delete all the curves and points, and then create a new part with the name manifold wall. And you can add the entities which belong to the newly created subset using this option, and select the subset. This will add all the surfaces that belong to that subset into a new part. Now we can delete the surface, not the surface, now we can delete the subset. But still we'll have those surfaces in this new part which we have created now, manifold wall. So now we have separated the inner surface from the outer solid surfaces. Piece of cake, isn't it? But this method might not work for few cases where there are some difficulties in importing the geometry, or when the surface definitions are not read properly in ANSYS ICEM CFD. But otherwise, the rest of the process is same as shown in the earlier video, which is nothing but deleting the unwanted solid surfaces and then run build diagnostic topology to identify the leak or yellow curves, and then use create simple surfaces and close these loops with proper name like inlet, this is same as that I've shown in the earlier video also. That's it. Once again check for the yellow curves. If you find no single curves or loop of single curves, you can conclude that there are no leaks or any openings. The geometry is watertight now. That's all for now. Hope to see you in the next video with a new tutorial. Thank you.